An experimental design is what I would term a strong research design. It's strong because experiments ensure that the test group and the control group are the same in every way, except one, variation in the independent variable. Therefore, any differences on the dependent variable can be attributed to the independent variable, can be causally attributed to the independent variable, since all the rivals are identical between the groups. Experimental designs are strong because they control for the possible effects of all rival explanations, even rivals the investigator has not thought of or those he or she doesn't even care about. So there's a liberating characteristic, if you will, to experiments because all possible alternative causes, rival explanations for the dependent variable, have been controlled for in the nature of the design. The key characteristic of experiments, which is random assignment. All experiments use random assignment. Random assignment occurs when every prospective participant, every individual the investigator wants to study, or every unit of analysis that the investigator wants to study, has an equal chance of ending up in the control group or the test group. The mechanism is randomness. We know we've talked about the beauty of randomness before, the methodological beauty of it. If you randomly assign, say, individuals to a test group and a control group, then the only differences between those two groups, before you do anything else, the only differences are random differences. And if the size of these two groups the sizes are large enough, then we know how much of the differences between them are purely random. Random assignment defeats selection bias. This is something we deal with in control comparison all the time. Selection bias occurs when non-random processes determine the composition of test and control groups. Random assignment defeats a selection bias. Random assignment ensures there are not compositional differences between the test group and control groups. I mean, that's the beauty of it. Compositional differences are referred to by some researchers as prior variables, that is, variables that existed before the experiment begins, before the study begins. As one of the citations in the textbook says, quote, "The intellectual beauty of randomized design is this: we do not have to know the names of any prior variables, that is to say, any compositional differences that need control. Randomly constituted classes will show only random differences for any prior variable, that is, any compositional difference whatsoever."